Okay, so it's my very great pleasure to welcome you to the latest in the DLM Forum webinar series. Just a few little housekeeping things before we get underway. First of all, can I ask everyone who hasn't already done so to mute their microphones, apart from the speakers, of course. Questions will be reserved until the end, and I'd be grateful, please, if you would put them into the chat. And then at the end, I will read them out to the speakers, and the speakers will respond. And I'm sure if you require further follow-up, we can get email contact with you and have a fuller discussion. So good afternoon, welcome. We have a couple of things to say. First of all, this is, I think, only the second day this year that the part of Ireland that I live in hasn't been raining, so I'm pleased about that. We have a very international audience and set of presenters today. We've got an audience that extends all the way over to Australia. Thanks, guys, for joining. And we have speakers based in Ireland, France, and Spain. So it's my very great pleasure to introduce Janet Anderson, Stephen Mackey, and Sven Schlaub, who will be speaking on eArchiving 3D models, and they'll be presenting us an end-to-end preservation solution for digital cultural heritage. Over to you guys, and I'll mute my microphone too.
David, could you just explain about eArchiving now being eArk Forum?
Oh, sorry, yes, of course. The eArchiving initiative was formally funded in its entirety by the European Commission. That funding came to an end last September, and the DLM Forum, I'm very grateful for them for doing this, have stepped in to provide us with a home. We continue to be the eArchiving initiative. We continue to have the support of the Commission, but we now operate under the auspices of the DLM Forum. Okay, over to you guys.
Thank you, David. Okay, so today we're looking at eArchiving 3D models, an end-to-end preservation solution for digital cultural heritage, or DCH. So we've got myself, Stephen Mackey, and Sven Schlaub. So we're going to start off with looking at the problem space, the DCH landscape, the peculiarities of trying to preserve 3D models, and what eArchiving has been able to do to address that. Then we're going to go on to the specifications, and that will be, so I'm doing the first part. The second part is eArk specifications. We'll start off with the general eArk specifications and then move on to the 3D ones. And that's Stephen Mackey, who's from Penwern Limited, UK company, but based in Brittany. And then we've got a practical demonstration using the software eArk Web by Sven Schlaub, Austrian Institute of Technology. Now, eArk Web is a reference implementation. There are other options, many other options that we have, and we'll talk about those as we go. So here's my first part. My 3D model is wonderful now, but will it last? So David and I first came into contact with 3D models preserving visualizations and simulations in 2012. Hope you can see that, 2012, when we had something called a POCOS symposium. Now, there were 3 symposia. There was computer art, software art, computer games, and visualizations and simulations. And the visualizations and simulations, we met Drew Baker. They were one of the King's College London, where Drew was working at the King's Visualization Lab. They were one of the other partners. This was a JISC project with the British Library. Now, this was a get-together with the DCH community and the digital preservation community to try and learn from each other what were the peculiarities of trying to preserve visualizations and simulations, and what could digital preservation do with it. Now, the result, one of the results of that symposium was an illustrated free ebook, which is still available. And here it is. preservation of complex objects. You'll have access to the recording and you'll be able to get these links after the presentation is finished. Now, what about the DCH landscape? Well, we found at that time there was no notion of digital preservation at all. And what the digital preservation community discovered was the highly, highly complex evanescent software and processes involved in trying to preserve visualizations and simulations. These were orders of magnitude greater than anything else we'd come across at the time, even computer games. The amount of metadata required about, for example, archaeological processes, actual physical digs, as well as the models themselves. And we came across this term paradata. And as an example, I'm going to just quickly talk about the ENAMI project, or not talk about it, just mention it. Many of you in the audience will have lots of experience of 3D models, etc. So you'll know all this already. But just for example, we met Daniel Pletniks at that symposium, at the POCOS symposium. He has now been working for 25 years on a medieval abbey at Enami in Belgium. And this abbey was extant for nearly 1,000 years. And Daniel has been doing archaeological digs for the major periods of that abbey's existence. So he's got all the paradata, all the information about the different digs, the different temperatures, equipment, all that data, plus the data about the actual 3D models. This is a huge amount of data and very important and different really from anything else around. So paradata. Now this was developed in 2009, something called the London Charter, and one of the people that wrote that was Drew Baker. Sorry, Drew, but you're important. Certainly in our story. Now, paradata is still important. So this is the data about the processes used in archaeological and other kind of digs and other kind of digital cultural heritage work. There's an open access paradata book, came out in 2025, and this is a really important thing. We did this talk to National Archives in Copenhagen at the DLM Forum, and when I asked the audience who knew about paradata, I was very pleased that lots of people knew about it. So it is definitely gaining traction. It is really important. So we don't just want metadata, we want paradata as well when we're looking at preserving 3D models. So there's a book that will help, an open access book that will keep you up to date. So where does eArchiving fit in this story? Well, picking this up, one of our project officers for eArchiving, and eArchiving started back in 2014. One of our project officers is Fulgencio San Martin, based in Luxembourg, and he is also the project officer or a project officer for Europeana, and preserving 3D models is very dear to his heart. So for our last procurement, the one that started in 2022 and has just finished, as David said, finding a practical end-to-end solution for preserving 3D models was something really important for him, for Europeana, and something that we were tasked to do. And all of you will have seen the Twinit calls to provide digital twins for cultural heritage. So when we're providing these twins, what is most important is that we are able to then preserve them. We do not want them to be just thrown away or inaccessible. We want them to be reused. So how did we go about creating a digital preservation solution for 3D models? Well, our e-archiving initiative. We had as one of our consortium members, we had Prisma, and particularly Franco Nicolucci, who was the technical director for 4CH, the 4CH project. So we were able to really benefit from that inside knowledge from Franco. Incidentally, two other members of Highbury have also been involved since 2004 with preservation. That's Begonia Sanchez Royo and Jamie Kaminsky. So we do have that with that link as well. Although surprisingly, they from the University of Brighton originally were not involved in POCOS. Very strange. And just incidentally going forward, where Highbury is involved with that's the company that in Ireland that David and I are part of. We're involved on the advisory board of the 3D Competence Centre, 3D4CH, and also members of Karari 3D, looking at 3D. So our task was to work on this solution. We had expertise from 4CH. And then incidentally, David and I were asked to be external examiners for the Nemesini project out at the Cyprus University of Technology. And we came into contact with Drew Baker again. And it was fantastic to be able to pick up where we left off with Drew. So we created or had already started to create a 3D network of experts. And if anybody is interested in joining that, we're still going to keep going with that. When we come to the end of the talk today, you'll see a contact us, and there'll be an info at email. Please contact us if you would like to join the 3D network of experts going forward. So some of those came from the DLM forum. We had various people, various talks at the DLM forum on 3D issues, and we built up a network of experts so we could talk together about what was needed for specifications and all aspects of preserving 3D models. Stephen, who you will hear from in a minute, developed a 3D family of specifications, and Sven worked on the e-ARK web and developed a solution that you will see for the reference implementation. Now I've added here, there are many other solutions possible. So for example, Keep Solutions, they have a repository. I shall be talking about a repository in 2 seconds. And they have digital preservation software that is used for very large scale challenges. So for example, the European Union Publications Office use Keep Solutions software. So whether you've got a small amount of data to think about or a large amount of data, we can guide you there. So we then presented, so that by that stage we had got an end-to-end solution. We then presented this at Euromed. This was in December 2024 in Cyprus University of Technology, again with Drew, and we really felt that this was a breakthrough moment with the DCH community. We had such a positive response from the audience who said that this was the first time they'd really seen a practical and usable solution to preserving 3D models. So, for example, there was Antonella Fraser from Eureka 3D, who then immediately added our little logo onto their big logo, their big kind of screen thing. So, some practicalities. So for the general problem space, how to preserve 3D models. Prisma, and we're going back to Franco De Colucci and colleagues, they, whilst in eArchiving, the eArchiving initiative, they produced a report, a long report, and I've got here the link to it. So please have a look at this. This is really important, and it was advertised on the website that we had before. And what was really important about this, I think, was that it spoke in the language that the DCH community could really cope with. Archivists have their own terminology. We talk about fixity and various different things. But this was delivered in terms that the DCH community would readily understand. So we talked about digital obsolescence, digital continuity, data, the importance of having data management plan to start with. It's no good creating your 3D model, taking lots and lots of time, and then thinking, oh, how should I preserve this? You need a data management plan from the beginning. The FAIR principles, those are well understood by many these days. So the European Open Cloud would understand the FAIR principle. So this is really important. So if you use eArchiving, eArk, then you are using the FAIR principles. It talks about public repositories and the importance of choosing a good one, and I will mention that in a minute, and paradata, metadata, and long-term digital preservation, and common 3D file formats for preservation. So where does eArchiving fit in? One thing is very important, and that is you can't just talk about storage or even just repositories. A repository can just mean just dumping stuff on a hard drive. That is not going to make it reusable or preserved over time. So just storing will not do it. You need a trusted repository. For example, an archive is a trusted repository. It's an organization that intends to preserve information for access and reuse by a designated community. So very, very important, trusted repository. So our eArchiving mission is to provide non-hosted archival services, but we'll give you guidance on everything else. So specifications, tools, reference architecture. Reference architecture is a very important model, goes through everything that you need to archive something in lots of different terms for different audiences. So very, very useful to preserve your material based on current best practices. And then it's getting something into a trusted repository, preserving and then enabling reuse. And again, that is exactly what FAIR is. And it's interoperable across Europe, so very important. So harmonized, supported by guidelines and recommended practices. And not only 3D models, we've got geospatial data, we've got specifications for those, databases, 3D data, etc. And our what we delivered at Euromed was written up as part of the 3D challenges in Cultural Heritage 6. And there's our chapter. And I'm now over to Stephen. So I will stop sharing and Stephen will now share on specifications, and then Sven will share and demonstrate.
All right, thanks, Janet. We just
Right. I don't want to leave the meeting. Cancel. Right.
can you see that?
Yes.
Excellent, thank you. So I'm going to talk about the eArchiving specifications, and I will start by doing a bit of review on the general specifications as a basis, because not everybody will be familiar and then talk in detail about the specifications that have been developed for 3D. So e-archiving specifications, as Janet has described, are there to provide a basis for interoperability of archiving packages. And they are an implementation or a specification for an implementation of an OAIS reference architecture system. So OAIS recommends the use of archival packages, but doesn't give any detail for the structure of these packages. And the e-archiving specifications fill that gap, providing very detailed specifications for the structure of the packages and for the accompanying metadata. And in order to do that, we provide a common specification, which has got the common requirements for all kinds of packages. But we also provide some texture in terms of the special requirements for, say, a submission package or an archival package or a dissemination package. In addition to that, we provide some guidance on the use of archival information, so descriptive metadata, and the use of preservation metadata, i.e. the use of premise. And the subject today is about 3D, and this comes into play in terms of these bottom layer, which are the content information type specifications. So these are special cases for requirements or guidance on how to archive particular types of data within particular use cases. And as Janet described, we've got SITs for geospatial data, we have SITs for databases, electronic record management systems, and in this case for currently 2 different types of 3D data. The specifications are managed and also have been managed outside of the e-ARK project itself, in fact, by the DILSIS board. So there's an independent governing body, and that is hosted by our good friends here at the DLM Forum. And if you go to the DILSIS board website, you can actually access the specifications, the guidelines, which are there to assist with implementation of the specifications, profiles and schema for particular METS profiles and metadata schemas. And there is a link there over to the GitHub repositories, which are where the specifications and the profiles are maintained. And if you do that, you can actually raise issues directly against the repositories if you want to actually contact the authors directly. So the purpose, and I think Janet has described this already, the purpose of the CSIP and the purpose of the specifications to establish a common understanding of the requirements that we need to meet to actually create an information package, to establish a common base in terms of the CSIP for more granular implementations, such as the package specifications and the SITs, propose a detailed implementation, ultimately with the goal of actually achieving interoperability. And the use cases for interoperability can be exchange of archival packages, submission of submission packages to a centralized repository, consolidation of archives, or even dissemination of content out to consumers. And most of the principles of the CSIP and the other specifications, in fact, are driven by this aim of interoperability. So it's to remove any scope for interpretation and actually give a very detailed specification and requirement so that packages will be interoperable and interchangeable between different systems and users within a wide variety of software and tools. And we do that within the specifications by laying out general principles. And you can see here I've given an example of a general principle, and then very detailed requirements. And many of those requirements get down into the details of the METS implementation, so METS profiles, metadata schemas, and the structure of the package itself. We specify the use of METS within the e-archiving specification, and there are very detailed requirements within the specifications for the use of METS. We have METS profiles at each level, and we actually created specific extensions to the schema, which you can find on the DILSIS site or on GitHub. And here's an example of a requirement within the CSIP. E-archiving specifications in the CSIP and the preservation metadata specification recommend the use of premise for preservation metadata. The inclusion of preservation metadata is not mandated, but if it is included, it is recommended that you use premise 3 and the data dictionary for premise 3, which many of you will be familiar with. And again, within the premise or the preservation metadata specification, we outline the way in that should be implemented if premise is used. And as we'll see further on, within the 3D content information type specifications, we go a bit further and we actually strongly recommend the use of premise or mandate use of premise for recording certain information and provide some more detail on how that can be done. So I talked about the specifications actually specifying a physical structure. The use of a physical structured information package is not mandated within e-ARK, but it is strongly recommended. But it can be actually proxied by a virtual structure. But by providing this, and you can see this is a much more granular and sophisticated structure than you might see in more generic AIP structures out there, typically based on Baggett. And in order to do that, we've actually created a much more detailed structure where different elements of the package can be located. And so, of course, this makes it a lot more easy to navigate in terms of finding the appropriate parts. So one of the objectives of the e-ARK package is to make this both machine and human readable. And to be human readable, the package really needs to be easy to navigate to find the elements that you're looking for. And I'll just point out a few elements here. You can see that there is a specific folder for metadata, both descriptive and preservation. There is the root mets file, which actually describes the structure and the manifest in the package. We have a folder of schemas. So in order to make the packages complete and self-describing, we recommend the inclusion of all schemas used, and an additional folder for documentation, which we'll come back to. And one of the fundamental features of the e-archiving specifications is this use of representations. So within a single package, you are able to actually present complete data structures in different representation forms. So for example, you may include original file structures and original file formats, but you may have migrated or normalized those files, and you would present that in a separate representation. So that way you can actually create an archival package which has a complete history of the content, but you can also add to that over time as, again, formats are migrated or normalized into new formats, and you can add further representations. So on to 3D. So within SITs themselves, in general, what we try to do is to provide sufficient detail that, first of all, you can qualify whether this actual SITs is actually appropriate for your use case, get some guidance on the kind of use cases it's applicable to, and then give the detail, sufficient detail, you can actually execute that either within your own workflows and systems, or you can examine systems that are available and see if they are compliant. So very importantly, the SITs include a scope to say where it can be applied. We try to include relevant use cases. And then as with the other specifications, we have principles and we have requirements around package structures and extensions to the basic structure. We include requirements for contextual documentation, for the minimums requirements for data and for data structure, any requirements for related standards conformance, and then, of course, the minimum amount of metadata, including things like profiles and schemas that are required. So the first specification that we produced was one for product model, the so-called 3D SITs, 3D PM. And this is used for the transfer to archives, records exchange, and archive consolidation within the 3D product model domain. So it's appropriate for CAD, for product models, for test models, model-based systems engineering, etc. And because of this, it actually builds on an existing European and American standard called LOTAR, which stands for long-term archiving and recovery and retrieval, sorry. And is published as EN on NAS 9300. LOTAR itself actually is based very heavily on the OAS reference architecture and on the ISO 10303, which in fact is STEP, the standard for exchange of product model data. Interesting enough, as LOTAR builds on STEP, eArch builds on LOTAR, and there is really no conflict between LOTAR and eArch, as LOTAR does not stray into implementation considerations for packages. And so in return, in terms with the 3D product model sits, we do not push back or interfere with requirements which are described within LOTAR itself. So the two are very complementary. So that was just published in 2024. And today we're talking about the 3D cultural heritage sits, 3D HM, which I'll talk about the schedule for that at the end. The scope for 3D HM is for 3D models produced as part of cultural heritage in any format or produced by any capture method. So we're trying to be as wide as possible in accommodating many different kind of models, which are described in some of the publications that Janet talked about earlier. Use cases, again, long-term archiving, interchange of models, or submission to a central repository. Basic principles: data format agnostic. There are no file formats out there which we could describe as being standardized, although there is guidance from Nicolucci and others about the formats which are likely to be the best for long-term archiving, but there are no standards. So we try to keep the sits to be as agnostic as possible. We do require the use of premise for recording preservation information. Package structure is extended, and we now include folders for paradata, as described by Janet, and for optional authentication, which is one of the key requirements of the 3D product model specification. That is the validation and verification of product models. Contextual documentation has to include paradata and submission agreements. Content data as described, we're recommending the use of open formats. We also recommend to keep originals, as you know, often the migration of content into different formats can result in information loss. Structural metadata, as for all the specifications in METS, and preservation of rights and technical metadata in premise. Descriptive metadata, I'll talk a bit more about, is a bit more of an open issue in that within the archival domain, chiefly we are recommending and is widely used are standards such as EAD or ISAG. But within this domain, the primary schemas are those such as Carrare and Lido. So there is a problem in terms of creating an archival package and including the metadata and be able to select a single schema for descriptive metadata. So just a word about paradata. Janet talked about this, and we have a definition within the sits just so that we actually define what we mean in the context of the sits of what is paradata. So in our world, it's supporting textual material which concerns the conditions under which the model creation took place, the intended purpose, the rationales, and the decisions taken in the process, leading to the final result, and references to the documentation supporting the reconstruction. So we've allowed a specific location. So previously in the packages, we mandated that metadata would go in a particular location, and there was a location for general documentation, but we're now specifying where paradata will go. There are no standards for producing semantically structured paradata today, although there's quite a lot of work going on in trying to move that forward. But there are, there is work, particularly by people like the Menazan project, in providing best practice for production of paradata. So paradata can be as unstructured or structured as you wish, and of course it should be produced as best you can in line with best practice. Linked on data ontologies like CDOC CRM can be used, for example, to provide more structured semantic paradata than just unstructured documentation. And lastly, on descriptive metadata, the purpose is, of course, finding archival content within your repository. And as I described, first of all, eArch demands the use of standards. One standard doesn't fit all for this domain, as it doesn't for many of the specialized content domains. And in order to meet the requirement, quite often schemas may need to be extended. You could actually work out local schemas, but that's not encouraged, as standardized schemas are encouraged. I believe, or we believe, that there is probably a solution combining available linked data ontologies such as records in context, which is the kind of follow-on from ISADG, and the C-ARK CRM, which is a linked data model which is produced specifically for initially the museums, but now more for generally for objects. So with those two and the elements they have in common, you can actually produce a linked data model which actually covers both the areas of archival description and description of the object itself. And I've got a description there, just a quick illustration of that, in that both REC and records in context and CRM have got column elements where you can actually use them together, but also importantly, you can use these ontologies to describe relationships between archival packages. One of the challenges, again, with these quite complex environments like product models and with heritage models is quite often that we're dealing with not just single archival packages, but large sets, and sometimes hierarchical sets and taxonomies of archival packages, such as for a complete product or system design, which consists of many, many models. And these, again, can be described in conventional metadata, but that is really quite clumsy, but are better described using some of these linked data ontologies, such as the CRM or records in context. So next actions, the 3D heritage model sits should be available for review, we hope, in April 2026. I've no doubt some mails will go out on the mailing list just to say that's available, and it will be available from the DILSIS board website and on GitHub. And following that, we're going to do a 30-day review, and hopefully then we'll be able to do a final publication in May this year. And following that, of course, it will go into maintenance review, and anybody will be free to provide feedback issues via the GitHub site. So I think now we move on to Sven.
Yes, thank you, Stephen. I hope you can hear me, and I will try to share. So you should see my slide as well.
Yes, we do.
So what you see on the screen is the Lambuza fishing trawler. I will try to give here a concrete example of how that looks like in the reference implementation that already Janet mentioned. The reference implementation shows how the eArch concepts, so the specifications can be implemented. There are different ways of implementing it, but the reference implementation just shows the use of the package standards, metadata, etc. in a system, especially here in a web-based system, so that anybody can access this instance and try it out. Also do ingest, for example, to look at how an eArch zip and submission information package is converted to an AIP and these kind of things. So here, the eArchive, the Lambuza fishing trawler, just to mention, all the credits go to the Digital Heritage Research Lab at the Cyprus University of Technology. They developed this. They developed also the paradata that belong to it. So everything is on their side. Here we just take it as an example for a more complex data set involving 3D cultural heritage data. Another picture of the fishing trawler here. It looks like a bit like a small boat, but it's actually quite big in reality. And if you want to read a bit about the history of the and everything behind that, it's under this link that you can get when the slides are sent out. So basically, the boat itself is an example of craftsmanship of how this boat was constructed on the one side. And on the other side, it's a bit this history of large fishing trawlers with heavy nets on the ground that was a problem in the European Commission and identified by the European Commission, and that's why it is in general of cultural heritage value, and there was the intention to preserve it in digital form as a digital twin, where you have a 3D model actually creating it. So here the creator that did it is the municipality of Limassol, and contributors here is the UNESCO Chair of on Digital Cultural Heritage and the Digital Heritage Research Lab at the Cyprus University of Technology. There's a link if you want to view the model, or you can just here use your mobile phone to open it. Should also open on your on mobile device, or use the link when we send out it afterwards, just if you want to a bit see how the model can be rendered on a simple device. This should then at the end look like this. You open the model and you can move it and see it from different angles. From here, we go into quickly into the eArch reference implementation, where we have here the view on a submission information package, where we create this submission information package. You see two representations, just to mention that representations is a core concept of the eArch specifications, because over the time, so if you do preservation actions and preservation actions need to be preserved, what actually happens is that you create new representations. For example, if a format becomes obsolete and you need to add a new format, here we create a submission information package just to show that also in the submission information package you can have different representations in different formats. Here for this 3D models, there's a GLB format, and the other one is an MTL format. So two different, completely different formats. So I think that experts in the 3D model domain will fully understand what these two formats are about, but we keep them as two different representations that are also documented separately. Apart from that, you have metadata about the data set in general. We have them in one representation, for example, here to show what is the data set actually about. This belongs to the documentation, several images of the boat itself, other kind of data that photos, so screenshots of the model, of a model rendering, etc. Anything that can help actually understanding the data set in its own, as well as the report on paradata complexity here. So all metadata that belong to the data set can be gathered in the documentation folder here. It's not structured. I will come to that, back to that later to explain a bit why there is need actually to have also structured and formalized metadata, paradata. And we can think about that. So here in the documentation folder is the paradata gathered. And this is the part where you go into the metadata of the eArch information package, where you have the descriptive metadata. In this case, you can, so Stephen mentioned that there is no general standard that needs to be used. You can have Dublin core. There is also an EAD example. You can have Lido metadata that is used mostly in the museums context. So different forms of metadata can be used and can be stored in the metadata descriptive folder. As well as here internally, the reference implementation also has a JSON format that can be used generally, and here a linked data in triples format, TTL. So all this belongs to the metadata component of the eArch information package. We have then in the preservation part, the premise examples. In the premise, for example, here is just one event that is recorded, which was the ingest. But over the time, you can imagine that once you take preservation actions, more preservation metadata can be added that record what preservation action was executed, what tools were used, and why a decision was taken can also be added. So these kind of information belong there. We have then here the METS, which is the structural metadata that shows which is here the one that belongs to the presentation, to the representation. This is because we have a nested structure where we have a root METS file in the root of the package. That is the overall structure that then references the METS files of the representations to keep them separated, because once you add a new representation, you only need to add the METS file, listing all the files and metadata of the new representation only, and then add the reference to it in the root METS file. So as I mentioned, there is need to have structured paradata. Also here mentioning a publication that explicitly states that there is need to actually keep also structured paradata, and that a problem is that there is a lack of universal standards for structuring paradata. If we think about how we do that in practice, we can use, for example, generative AI to help building the model, to at least get the first concepts that we need to build it. We can generate it using, in this case, as input the paradata itself. And what comes out is, I would say, maybe the basis of a discussion, the basis to modify the model and to start thinking about how the model could look like. As you can see, with linked data, you have the possibility to use different schemas. So here, this integrates also the premise schema. So how could a paradata conceptual schema look like that integrates the different standards into one conceptual model and then being able to structure the paradata accordingly? So that's the idea here, just as I mentioned, generated with the help of GPT-5. And as a glimpse into the future, how it looks like working with models will change significantly. So this is an example where we could use agent-based 3D model manipulation actually by using agents. That's a new topic. If you heard about OpenClaw, and here together with MCP, you can actually start doing modifications of models and ask yourself, okay, how do we, in eArchiving, how do we document these actions? In this case, we have the boat in Blender. So Blender is one of the software that can be used to render these models. And here, just as an example, the task to automatically identify the Lambuza deck and then put a new object on the deck. And how do you interact with it? So actually, you just tell it via one of your clients. That can be a Telegram client that you talk to the model and tell it here, have a look at the Blender model, and can you please add an object to the deck? And you see maybe the box that was added here. So just to mention that by this way, the environment actually can identify, so what's the deck of the ship and how can you add a new object to the deck? And then the question is how to document it. That was just a final glimpse into how the future can look like and how that will impact our work in the eArchiving community. That was it from my side, and I gave back to Janet and David.
Okay, before Janet makes any closing comments, can I remind you to add any questions that you'd like to ask into the chat? At this moment, we have none, but I'm sure there are questions that you'd like the speakers to address.
Yeah, just to say, if you would be interested in joining our 3D network, please contact info@eark.online. If you have any other queries, support@earkfoundation.eu. We've got a mailing list, so please join that. So if you go to this, you'll see here we are. Here's the subscribe to our newsletter. So please feel free to do that if you haven't already. And we're on LinkedIn. And now archived is our previous EC webpage, our eArchiving webpage there. So next slide is questions, if there are any.
Well, we have one at the moment. The question is the Paradata model a bottleneck for releasing the new 3D sets, or can they be released separately?
That's over to Stephen.
Yes, a good question, Kieran. The short answer is no, it's not a bottleneck, because the current specification will always default down to what is achievable. So we currently specify that there is a location for Paradata and recommend that Paradata should be included, but that Paradata can be in any format currently. There aren't sufficient standards out there to be any stricter than that. So as the model becomes available, then of course that will be available for people to use. And if there was a standard created and reached a sufficient level of maturity, then we could actually mandate or strongly recommend its use.
And Marinos from the Cyprus Institute of Technology shared the Mendocini principle for Paradata here. So that's the work so far on Paradata, apart from the open access book that we shared as well. Over to you, David. There's more questions.
There are indeed. So have we been using LLMs to create Paradata?
Mm-hmm.
Not that I'm aware of. So here the experiment was just to convert existing Paradata into a formalized version as a basis to build the conceptual model. But it was not used to create the Paradata itself, as far as I'm aware.
Okay, there's a question directed at Janet.
Right.
Janet, you mentioned a timeline for releasing the new HM spec. Did that come out as the question, or has Kieran missed that?
The timeline for the spec. No, Stephen shared that.
Oh, okay. Well, Stephen, you answered that.
Yes.
Yeah, Stephen.
So we
Yeah,
are
go on.
hoping for a public review, 30-day public review of the specification in April this year. And as long as that doesn't come back with too many changes, then we'd be looking for final publication in May. That's the current schedule.
Okay.
And we were hoping to do a 3D sits for BIM as well, but our initiative finished a year earlier than anticipated, so that didn't get done, but there's probably still interest in it.
Yeah. Okay, there's a small correction from Marinos, which I'll leave you to read in the chat. Another question: for many small organizations that are producing 3D data, time and funding are limited. Yeah, for all organizations doing everything. Are there any easy to use tools to create a bare minimum archival and dissemination data packages, step-by-step guides for improving existing data packages, and so on?
I think what Sven did with the eArch web, there is no royal road to digital preservation. You have to record your metadata and paradata, and the bigger and the longer your project, the more there will be. But having recorded that, it's straightforward, fairly straightforward to put that into eArch web. And the specifications, there's guidelines as to how to use the specifications. Sven, there's guidelines as to how to use eArch web.
There's we also, it's separated. So we also have, and the basis of it is a Python development stack and the Java development stack. So on the Python side, we have the reference implementation that is using a tool called EATB. This is a basic package that can be used to create the metadata necessary, which means it builds you It builds you the METS structure, for example, to start with, this nested METS structure that I've shown. It also includes premise handling, etc. It's a basis to build that. So these tools exist. On the Java side, there is the so-called Commons IP, which is a base library that can be used and that is used actually by Keep's repository solution, Rhoda. So on both sides, there are free choices that can be used if you don't want to use the full model. But also eArch Web in itself is free. Open source can be downloaded and used for that purpose as well. So this is definitely something we have there. And the reference implementation, actually, if you go through the process, it helps you. There is a zip section, so you can create a submission information package. You can ingest it and just see how the process goes, just to see how it works. And there are examples in there of the Lambuza boat, for example, or other database eArch-based packages, so that there are different packages that give examples of how that works in principle.
Okay. There are no further questions at the moment. If anyone wants to ask another question, this would be a really good time to get typing.
And I think as Stephen mentioned, the specification helps you to either put something in your own archive, your own repository, or to put it into a trusted repository. For example, and the one that we used in our chapter in the book was the Digital Repository of Ireland. That is a trusted repository. It's got Core Seal Trust certification, so you know that it's trusted. And if you go to put something in there, you will have a whole list of things that you must do. So whether you're doing it for yourself or you're putting it in somebody else's repository for them to look after it, your work long term, you still have to do those same basic steps of describing the metadata, describing who created, etc. All that metadata and paradata is all necessary. So that's the step-by-step process. And as for the standards, I mentioned that long report by Prisma and Franco Nicolucci. That's the one that goes through all the different standards and the step-by-step process. And the chapter that we had in the book, so that's this chapter here, that goes through and sets out everything that we said. So this chapter here. So there's our chapter. So it describes step by step everything that we've done today. Sorry.
Okay,
So hopefully
it seems also there was a comment from Marinos, no, that we should use the research center Mnemosyne to give the credits, I think.
Yeah.